There's antimony, arsenic, aluminum, selenium, and hydrogen, and oxygen, and nitrogen, and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium.
Good evening, ladies and gentlemen. Today's latest news is the discovery of the periodic table. The story of this discovery is indeed a very interesting one. Max Freudenthal, brother of the famous scientist Tanja Freudenthal, found it under his house. The periodic table is part of the research that Tanja Freudenthal has recently gone into. Thus, she is having a conference in this minute in which we will be granted with this important facts. Now, live with Tanja Freudenthal.
Ladies and gentlemen, press and the world. I'm here today to talk about the most recent discovery, the periodic table. I will answer all your questions. Now, let's begin with my presentation. What is a periodic table? Well, this is easy to answer. It is a graphic display of the chemical elements. But the question now is, what is a chemical element? We made a survey to see who knows the significance of what an element is. So we will see this right now. Courtney, what is an element?
An element. Yeah, I can't think of an answer.
What is an element?
Ibas a preguntar otra cosa.
No, espérate. Dime qué responder. What is an element?
It's a very small component,
No,
almost
porque no, Jorge sí sabe.
to an atomic level that makes up for most of the matter in the world.
What is an element?
An element is a part of something, the part that constitutes something. A chemical element, okay, that is the one that is formed by protons and neutrons, maybe.
As you can see, humanity is ignorant about the topic. Few people nowadays, and its majority scientists, knew about the existence of this periodic table and the elements. An element is a substance made of only one atom and it cannot be broken down. An element is defined by its atomic number, this one, which derives from the number of protons in its nucleus. An element can refer also to a pure chemical substance composed of atoms with the same number of protons. As you, my ideas, can see, the periodic table has many different colors. This has to do on the way the elements are organized. First of all, the columns are called groups. And the rows are called periods. Right? They are divided in non-metals, metalloids, metals, alkaline, alkali, lanthanide, actinide, and noble gases, which are this ones. All of these are highlighted in different colors so people can identify the element. During this presentation, I will tell you about all the elements that are presented in the periodic table. With each slide, you will be able to see an image that shows you where each of these elements are located. Please focus on the color so that you can see which of these elements are there. Non-metals are not strictly defined. They show characteristics like poor heat and electrical conductivity. They form acidic oxides, have low densities, and low melting point. Metalloids have properties of both metals and non-metals. This property makes metalloids useful in electronic components. Metals. This is an element that readily loses electrons to form positive ions. It is lustrous, deductible, malleable, and it is a good conductor for electricity. Alkaline earth metals tend to lose 2 electrons to form a doubly charged positive ion. Alkali metals are highly reactive and tend to not be found in elemental form in nature. Lanthanides are very reactive. They are sometimes classified as rare earth metals. They have many scientific and industrial uses. Their compounds are used as catalysts in the production of petroleum and synthetic products. Actinides are radioactive. They are highly electropositive. They are very dense metals with distinctive structures. They react with boiling water or dilute acid to release hydrogen gas. Actinides combine directly with most nonmetals. The periodic table of elements is organized in a special way so that we can get out all the information that we need. First, we have the name of the element, which is usually below the element's symbol. Above the element symbol is the atomic number, and below the element's name is the atomic mass number. Thank you all for your attention. This has been my pleasure.
Zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, and terbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and abyssal, chromium, lithium, beryllium, and barium. Isn't that interesting? I knew you would.
Thanks for watching the latest news. Good evening.